we're going to go on to the wonderful maths resources, and I think, Liz, you're going to help me out with this. Is that okay? Can we just navigate our way to the main website and the homepage, please?
We can indeed, David. Yep. I'm hoping that you can all see on the screen the homepage of the natural curriculum. David, can you see that?
Yeah, I can see that. So we've got the grammar lessons there at the top. I know many of you will be familiar with those. And if you're not, do check them out after this webinar. But our focus, of course, is these problem-solving maths lessons. Another way of bringing the natural world into the primary school's curriculum. So I guess the obvious place would be in science. But if we can kind of bring it into all aspects of the curriculum, then that can only be a good thing for the children. And I want to talk to you about a particular lesson. As I say, I am teaching year 6 this year, but last year I was teaching year 3. And I just want to show you a lesson that's really stuck in my mind, and I'll explain why shortly. Liz, can we go to the year 3 program, please?
Of course. There we go.
You'll see here, this is kind of like an adjective, or like all the topics there. So you've got number and place value, number and estimation. You've got 3 different kind of lessons to choose from in each of those topic areas. But if we go to the measurement one, and you'll see you've got magic narwhals there, titanosaur, and saguaro seeds. And if we go to the titanosaur lesson, and bring that one up, please, Liz.
That's good.
There we go. So, I mean, straight away, you know, you start talking about dinosaurs and you've got the children's attention. So I think you'll all kind of be able to relate to that. Every single lesson is based on a wonderful natural history clip from, you know, from the most recent series like Planet Earth 2. Well, in fact, it's now going to be Planet Earth 3. I think we're going to be drawing clips from soon. Blue Planet. This is a clip from Attenborough and the Giant Dinosaur, and I used this lesson with my year 3s. I thought it was just a great way to kickstart a kind of a unit on measurement and length. And of course, the beauty of these clips, they're just short. The BBC has done a fantastic job of taking all those groundbreaking series and just giving them in these bite-sized chunks that just work brilliantly in a lesson, whether it's at the beginning of a lesson or in a plenary, wherever you might want to use them. So I don't know what you were thinking then about how you might use that clip to inspire learning in a maths lesson. But Liz, can we go to the main problem and I'll show you what the children had to do?
Yeah, so I'm just clicking on the tab at the bottom here where it says the problem.
Thank you.
There we go.
And the problem. The picture opposite shows what scientists think the complete skeleton of a titanosaur might have looked like. So all the children have that picture in front of them and they've all watched the clip. And from this picture and from the fossilized titanosaur femur bone featured in the clip, what we wanted the children to do was calculate the approximate length of this mighty dinosaur. And I really like this lesson because it was a kind of a classic kind of enriched sort of lesson where you've got this kind of low threshold, high ceiling nature to it. And I'm not going to say much about that now because I know Liz will probably jump on after me and talk a little bit more of the importance of those sorts of challenges. But fundamentally, it meant that every single child in the class could get started and have fun and get excited getting started on the challenge, and it meant that every child could ultimately get stuck on it as well. After kind of introducing the problem and just, as you can see there, you've got the visualizing the problem and getting started. So a few kind of questions just to draw them in, ensure everybody understood what was meant by length, ensure that everybody could kind of locate the femur bone on the actual dinosaur itself, the titanosaur. Once we'd done that, it was great to see the children go off. They were working in pairs. A couple of things that I saw that was so exciting for me teaching the lesson was that the children got started straight away. The conversations were immediate. There was great dialogue, them talking about what they wanted to do. They were essentially infused by the independent challenge, and that was just great because that, you know, I knew that, you know, I was on to a winner there with all children kind of engaged in the activity. And then what was wonderful, wandering around the class, listening to the children, watching the children, kind of probing the children. there was such a range of strategies. So one end of the attainment spectrum, you had Kieran, who had decided that it was essential that he measured my height, because he'd figured that David Attenborough in the clip was a similar size, perhaps slightly smaller than the femur bone itself, and he thought that I would be a similar size to David Attenborough, so hence got the measuring sticks out, started measuring my height, which was wonderful, but then took it to that next step where he was able to figure out that I think something like 2 centimeters of that femur bone must have represented something like 2 meters in a real context. So used it some scaling, and from there was able to deduce the length. Other children in the class, for example, Suki and I think it was Tia, and I caught them cutting out little bits of paper, and they'd made a tiny little bone itself, which was the same size as the bone on the femur bone of the Titanosaur. And then what they were doing is they were moving that bone along the whole length of the Titanosaur. And of course, you know, that was great because they hadn't yet got a really good understanding of metric units, but they had got a good sense of units of length. And that was just a fantastic starting point for them on their learning journey that was to follow on that unit of measurement and length. And at the end, it was just great to see all the children kind of coming to the front and talking about their measurements. It just so happened that most of them kind of got a measurement between 20 and 40 meters for the full length of the Titanosaur. It just so happened they were really excited to learn that the Titanosaur was about 30 meters long, paleontologists think. So that was really exciting. And then we decided to go outside, and we realized with our trundle wheel that the playground could have actually have kind of fit a Titanosaur just about on it. So that was really exciting. Liz, if you just go to the final challenge, the final page, sorry. And there are a few extras there that you could do to follow this up. I wish I'd done this, but sadly, I think, you know, I call our curriculum the conveyor belt curriculum. Sadly, you know, things tend to go off the end of the conveyor belt too quickly before we can kind of follow things up. But had I got another opportunity, it would have been great to get the children to perhaps chalk out the Titanosaur on the playground, and then kind of work out what various body part lengths might have been, and do a bit of work based upon that. Maybe another time when I teach year 3 again, who knows, might be next year.